A chemical reaction close to my heart? That's easy. The reaction that takes place between a grill and a burger. Understanding reactions lies at the heart of chemistry. I just hope they all taste as good as this one. This is Real Chem. Cooking is chemistry. The cheeseburger is actually a great case in point. This shows two major classes of transformations, physical and chemical. Melting the cheese is a physical transformation, while browning the burger is a chemical one. We can sense changes in color and smell, sure. But the real action relates to what is happening at the atomic level. In a physical transformation, we see changes in the interactions between molecules. As the cheese melts, the molecules remain intact, but they go from a solid, where the particles stay fixed in some nearly static arrangement, to something more liquid-like, where they are free to move relative to each other. In a chemical transformation, the molecules are transformed into something new. This is what is happening when I brown the burger through something called the Maillard reaction. This reaction on my burger is an example of an oxidation-reduction reaction, or redox for short. In these redox reactions, an electron is being transferred from one molecule to another. The Maillard reaction transfers electrons between the amino acids that make up the protein to sugars, creating new molecules called melanoidins. They give the brown meat its incredible flavor. Redox reactions are very common. The combustion of natural gases in a burner, or the caramelization that makes the onions so tasty, both redox. When I eat this, my body digests it through what? Yep, redox reactions. Alternatively, an acid-base reaction requires the transfer of a proton. Acids are common in your kitchen. Vinegar is acetic acid. Oranges, lemons, limes all contain citric acid. In ceviche, acids such as these are added to raw seafood to essentially cook them. The acid molecules transfer protons to the protein molecules in the seafood, chemically transforming the proteins to essentially cook them without using heat. In making the buns for a hamburger, the dough rises due to carbon dioxide gas produced from an acid-base reaction between baking soda and more acidic ingredients like buttermilk. We also see precipitation reactions. In these reactions, molecules dissolved in some liquid come together to make an insoluble compound that drops out of solution as a solid, like making clarified butter, where butter is heated so that water and milk solids in the butter form a new precipitate that can be filtered away, leaving beautiful and delicious melted butter behind. In order to bring these reactions about in the kitchen or in the lab, we do, of course, need to combine our ingredients very carefully. In chemistry, we call this stoichiometry. Making reactions happen is fun. This unit takes us through the world of chemical reactions, focusing first on the differences between physical and chemical changes, and then unpacking the different classes of reaction. Stoichiometry comes next, where we use moles and mass to better understand, predict, and control reactions. So next time you bite into a burger, think about the incredible reactions taking place inside, and then enjoy it. Now let's get to work. This is Real Chem.